What's up people, welcome back. In this video of the subject automata theory and compiler design, we are going to learn the topic of compiler design and its phases. So let's begin. First one, we have an introduction to the compiler design. Now it is a fundamental aspect of a computer science and software engineering where it plays a very crucial role in the development of programming languages along with software applications. It encompasses a broad range of theoretical concepts along with practical techniques, which includes the automata theory, parsing algorithms, optimizing strategies, and code generation principles. Now, next one, we have an overview of automata theory. The automata theory is a branch of CSE which deals with the study of abstract machines and computation models, which includes the behavior and their properties. It allows for a theoretical foundation for its understanding of the design and analysis of algorithm, programming languages, and the principles of computation. Next one is types of automatas. Now these are classified into various types such as finite automata, push-down automata, and Turing machines. Each type has its unique characteristics and capabilities, which play a very important role in solving of computational problems. Now, what is the relation of an automata theory and the compiler design? So, they are closely related as many concepts and algorithm techniques of these are used in lexical analysis, syntax analysis, and code generation phases of the compiler construction. And by understanding these, and the need to understand these is crucial for building of robust and efficient compilers. So, the basics of compiler design. First one, the definition of a compiler. The compiler design is the process of creating a compiler, which is a program which can translate code written in one programming language into another. Now, what's importance? Now, it is very important as we understand the basic of its design, which are crucial for especially for software developers, which enable them to write and prioritize the optimization of code. Okay, so here we are starting the phases of compiler design. First one is the lexical analysis, where we learn about tokenization. Here, this is the first step, which involves breaking the input source code into meaningful units called tokens. These can be identifiers, keywords, operators, or symbols, which serve as the foundation for further analysis. Now, the next step is lexical error handling. These must efficiently detect and report any errors in the source code, such as misspelled identifiers or any invalid symbols, as these ensure the robustness and reliability of the compiler. Next one is the symbol table generation. Now here, it maintains the information of the identifiers present in the whole source code, including their names, types, and scopes. It is used in subsequent phases for referential and validation. Now the next phase is the syntax analysis phase. Here, we'll need to learn the syntax analysis phase of compiler design to analyze the structure of the source code to ensure that it is defined by the programming language. Now, it involves the use of formal grammar rules and syntax diagrams to correctly identify arrangement of tokens and the relationship with the programming language. Now, what's its role? That it helps in detecting and reporting syntax errors, which includes missing of symbols, missing mismatched parentheses, etc., which is an integral to the compilation process as it lays the groundwork for subsequent phases such as semantic analysis and code generation. The next phase is semantic analysis. Here, it involves interpreting the meaning of the code based on the grammar rules of the programming language. It includes understanding the context and semantics of the code to ensure that it makes a logical sense and adheres to the language specifications. Next one is type checking. It is a crucial part of semantic analysis. as it ensures that the typed expressions in the code are compatible and consistent along with the language typing system. It helps in identifying potential errors and ensures the typing safety in the code. Next one is optimization, which involves performing optimization tasks such as constant folding, propagation, and other transformations to improve the efficiency of the code. Now, the next phase is the intermediate code generation. In this phase, there is a conversion of the pass code into intermediate code and transformation of intermediate code into low level target code. It improves the efficiency and performance of the intermediate code and its mapping high level language constructs and the control structure representations is used in mapping of high level languages construct into intermediate code form. Now, this is a crucial step of the compilation process as the pass code is converted into the intermediate code. During this phase, the code undergoes the transaction or translation into a low level language. The resulting intermediate code is essential component in the compilation process. Next one is the code optimization phase. Here for the redundant code elimination, in this phase it eliminates redundant code to improve the efficiency and performance of the code generated. It involves identifying and removing code segments which do not contribute to the overall functionality of the program. Next one is the loop optimization. The compiler analyzes loops within the code to optimize their execution and minimize unnecessary iterations and reduce overhead as well. This is a technique which uses loop unrolling and loop fusion, which enhances the efficiency of the looping structures. Next one is inline expansion. During this, the code optimization phase, the compiler may perform an inline expansion to replace function calls with an actual body of the function. This reduces the overall head function calls and improves the performance of the code generated. So the last phase is the code generation phase, where it is the final step in the processing transforming of code source into executable code. Here in this phase, it takes the intermediate code which is generated in the previous phases and translates them into machine code or assembly language instructions which can be directly executed by the target computers. It involves the mapping of intermediate code of target machine into instruction set architecture, optimizing the generated code and handling low level details such as memory management, register allocation and instruction scheduling. Now, one of the key objectives of this phase is to provide efficient optimized code which effectively use the target's resources. Now that's it for the video guys. I hope you like it and you can give your thoughts in the comment section below. Thank you.